Hello, everyone. Thank you for joining the session of Mirantis Lab Tech Talks. Good morning, good evening, good afternoon, wherever you are all from. Uh, Please feel free to use the chat window to let me know where you are from. We would love to know where you are calling from and what is your Kubernetes journey so far. Um, with that, what we do at Mirantis Lab Tech Talks is we dive into cloud native topics, talking about like different tools in the CNCF space and the use cases around it, so that you can kickstart your Kubernetes journey or the modernization journey with the help of like the foundational concepts that we'll be walking through here. With that, today I am going to talk about multi-tenancy and then the virtual clusters. It's one of like the CNCF project that is out there that helps to boost how we do multi-tenancy. Without further ado, I will get started. Let me start sharing my screen. I hope you all can see my screen. Feel free to use the chat window to let me know if there are any troubles with my audio or with my screen share. So once again, I'm Avinash Desireddy. I am a senior solutions architect and then developer advocate here at Mirantis. Today, we are going to talk about like multi-tenancy and the isolation using virtual clusters, also known as vClusters. This is a basic foundational topic or like concepts where I'm going to talk about like briefly about like multi-tenancy, and then we'll dive into like how vClusters help uh, help achieving true multi-tenancy in the Kubernetes clusters. This is a like short disclaimer that I wanted to that our company wants me to put together. Uh, is like all these content like that is being shared here should not be referred directly into the contract without like in order to make purchase decisions. There should be additional details that needs to be considered in order to use this content accordingly. And I've already like told about me. So just a little bit more about me. So I'm Avinash Desireddy, and I've been in the cloud native space for a while, and I do all things Kubernetes, like helping customers in terms of containerizing their applications or like building clusters, like implementing CI/CD practices, and many more. Currently, in addition to that, I also like run like Mirantis Labs, where you are listening this talk mainly to uh, educate all of you on the cloud native topics. You can like reach me directly on Twitter if for any questions, and also like feel free to connect with me on LinkedIn. Okay, a couple of housekeeping items before we dive deep into it. The Q&A panel and the chat panels are available. Please feel free to use the panels like to post any questions that you have, and I'll be like providing the slides and as well as the recording in a follow-up email to you all. And if there are any like specific questions that you'd like to ask or you'd like to contribute to, feel free to click the button like ask to talk, and then I can allow you to speak and share your thoughts. With that, what are we talking going to how is this talk structured is we are going to talk a little bit about like Kubernetes architecture. Some of you might be familiar with it, but I'm not going to like spend too much time talking about the architecture, but just touch on the basic building blocks. And from there, I will dive into like what exactly is multi-tenancy and how it can be achieved or how it is achieved in a Kubernetes cluster. So we'll just like get some basic understanding about like multi-tenancy, and from there we'll understand like the limitations, like is the multi-tenancy that is inbuilt into the Kubernetes clusters, is it sufficient, or what are the challenges with it? And from there, we'll talk about like vClusters. And I'm not gonna spend like too much time on like the slides, and we'll just dive right into the demo as quickly as possible, like as we go as I go through the foundational concepts. And in the demo, I'll be using like a mini cube cluster where we'll be creating multiple V clusters, and also we'll look at different objects that are created, and then how we can interact with these virtual clusters. And then we'll just look at like a quick summary of achieving multi-tenancy using the core primitives in Kubernetes uh, versus vClusters. So with that, just like another quick note. So if you have any questions, feel free to post them in the chat, and then I will monitor the chat window in parallel and then get through it throughout the session. Okay, with that, let's dive into Kubernetes architecture. I don't want to like dive into like the benefits, it's like multi-tenancy is like an advanced topic, and then I believe like a lot of you have come across Kubernetes and then the benefit it provides. Now, just like talking about like the architecture, the Kubernetes architecture consists of like two set of nodes, like the control plane nodes and the worker nodes, which are also like referred to like as like the machines. Each node can be on its own physical machine or on a virtual machine. So like a node can be like an Amazon EC2 instance, or like a Google Compute Engine, like a node in a Google Compute Engine, or or VMware like a single instance, or it can be a like a physical machine where like only OS is installed on a physical server and then added to the Kubernetes cluster. So so all these can be treated as a node. And diving deep into like control plane, so control plane has like different components like API server, scheduler, controller manager, like cloud control manager, for the cloud environments, uh, are like the key components that make up the master node, or like the control node. And then there are like additional components like cluster DNS and etcd, which are like critical in the architecture. And the worker node, in order to like run the workloads, there should be container runtime, usually like Docker or Containerd, like container runtime environments, and we need to have kubelet and the kube proxy. So just to give like a quick overview, like there's a lot of information in this slide in terms of what each and every component does, but just to like dive a little bit deep into it, like an API server like tracks the state of the cluster components and manages like the interactions between them. Like every time like a user like submits like a request or like tries to communicate with Kubernetes cluster, the request comes to the API server, and then API server then interacts with like other components in the cluster to meet the user request. It can be like as simple as create a pod, or like look up the nodes in the cluster by using kubectl get nodes, or trying to look up any information, like any kubectl request like to the cluster will come to the API server first, and the API server will then respond to the user uh, after communicating with like different components as needed. And the second key component is like the scheduler, where like it distributes like unscheduled like workloads across the cluster. So it's one of like the critical component where it makes a decision based on like the given input, where and then state of the cluster, where where the pods needs to be deployed, etc. And there are like a controller manager like that runs all, like which runs all the built-in controllers, like replication controller. For example, if a pod goes down, it needs to be recreated, and the replication controller will ensure that. And similarly, there are other controllers like namespace controller. Like if yeah, uh, if like a namespace needs to be created and then it needs to be ensured, so like there's a controller around it. So there are like several built-in controllers that will ensure the target or like the final state of the Kubernetes cluster. And the cloud controller manager is like a special type of controller manager where it is used to manage the cloud resources, like adding more nodes in the cloud environments. Like for example, in Am- uh, AWS, let's say if new nodes needs to be added, then the cloud controller manager will take the responsibility, or in terms of creating a DNS entries or like load balancers, etc. Then we have like cluster DNS, like as the name suggests, like it provides like a cluster level DNS for all the services and pods that are created. And etcd is like a key value store, like for all the cluster configurations and data. Now, like talking about like the worker node components, like more in detail, like container runtime, like implements like the CRIs, like container implements the CRI container runtime interfaces, like containerd and then like IO. The container runtime is responsible for running the actual containers that a pod abstracts or like on a physical node. And the kubelet is a kubelet process that lives on the worker node is will talk to the API server and manage all the containers on the node. That means like kubelet receives the instructions on if a pod needs to be scheduled or like started on a node, and then based on the specification that it receives from the API server, it it reads that particular configuration and sends it to the container runtime. Like it can be like starting a container with a specific image and uh, opening up or like mounting specific volumes. Like all the information that it receives, it just passes to the container runtime. And the kube proxy is like the other key component, which accepts and controls like the network connections. Now, like kubelet will interface between the API server and then the container runtime. Now, our container runtime is responsible for like running the actual containers. But if two containers needs to interact with each other, or like if the pods across the nodes or like needs to interact with each other, that's where the kube proxy comes in, which performs all the necessary networking configurations and also like accepts and controls like the network connections like to the nodes. So, on top of all this architecture, like there is like a kubectl like command line tool for kube API that enables and operates like to execute like commands against Kubernetes cluster. Like I've mentioned like earlier, right? Any interactions to the API server like is done like by kubelet or any of the API calls. So that's interface like to the API calls. But one of like the powerful tool that abstracts a lot of user that abstracts the API calls to where it performs the necessary authentication and then submits our objects to submits our configuration objects to the API server is with the help of kubectl. With that, let's talk about multi-tenancy. What is multi-tenancy is it's an architectural model like where like tenants like share like uh, resources with each other, resources in a shared environment. Just to like better like put it in context, it is an architectural model, and like let's define a tenant like before we dive into like multi-tenancy. Like a tenant can be a team within an organization like that is responsible for like developing and operating like one or more workloads. And once like a tenant is defined, they need to work like they need a specific share or certain resources in a cluster. So like they can be assigned with a dedicated cluster, or they can use a shared environment or a shared cluster, so that they can make use of so that the underlying physical resources are used more efficiently. So usually in the multi-tenant model, like the resources are shared. Mainly, the majority of the resources that we are talking about is like the compute or like a memory or like the network. We can say, like for example, a team working in marketing org, they wanted to maintain certain applications to perform uh, for their marketing initiatives. So instead of like them building their own cluster, they can say we just need like 100 gigs or we just need like X amount of memory and then Y amount of like CPU for during certain times, or like all the time in so that we can run our application. So the uh, platform team like which runs like a shared cluster can provide the necessary resources to that particular cluster. So what is like the benefits of like multi-cluster is it's like isolated and secured. uh, like that means like we can achieve multi-tenancy in different ways. One is like building dedicated clusters for each tenant, or it can be a single cluster where multiple groups are access the single cluster, and just the resources are uh, or like the access to different tenants within the cluster is restricted with the help of authorization policies. In this case, like in the picture, like there are like three tenants that I'm referring to here. Is like one is blue, green, and red. And the blue tenant needs its own space to deploy the applications that belongs to the blue tenant, and then the same applies to like green and red. And the platform engineer or like the platform engineering team is responsible for onboarding these tenants securely into this cluster. So, how we can achieve like multi-tenancy in Kubernetes? Like, does Kubernetes have like some inbuilt objects or like inbuilt ways of uh, enabling multi-tenancy? Like the answer to that question is both yes and no. Like there are certain objects that enable enable us to group resources within a cluster. One of like the core the foundational resource is like the namespace. With the help of namespace, we can group or like in a namespace, we can group all our objects. So every object that we create, it belongs to a namespace, and all the naming and everything is like tied to that particular namespace. For example, if you are creating an application called Nginx, we can say Nginx belongs to a namespace blue or a namespace green. So that way, even if you have like a same name for the application called Nginx, the namespace in which it gets deployed, like creates the necessary differentiation. The diagram here on the right like refers to it, where like in like tenant one, where we can say like blue tenant uh, is uh, is is assigned with a specific namespace, and all the objects that are created like services or pods like deployments, they all are present inside this specific namespace. So we can say like the tenant has access to this particular namespace. And the few other like core building blocks that helps to achieve like true multi-tenancy, like the namespace just provides like just like a logical isolation around the resources around different objects in Kubernetes. But how we can make it more secure, like for example, if we have like tenant blue and tenant green, and we don't want tenant blue to look and or to view or manage resources in tenant green. Uh, we can achieve that by setting up like different access controls, like role-based access control, and also like with the help of like network policies. And let's say if one tenant has a certain number of resources or like that they need to access, because if both the clusters are shared, let's say if the cluster is of uh, uh, size 100 GB in memory. It's like the overall like the nodes that it adds up to. We don't want tenant one to use all the memory that's available in the cluster, or tenant to use all the memory in the cluster. There should be some boundaries on how much resources that they can use, etc. So that can be achieved like with the help of resource quota and limit ranges. So there are like different building blocks like namespaces, like the role-based access controls, like the limit ranges and quotas, network policies. All these different blocks will uh, help us to achieve multi-tenancy in a Kubernetes cluster. But managing these different objects and connecting with the logical groups like tenants is always hard. We need to have uh, clear processes and policies in place uh, so that a single tenant is assigned with one or more namespaces, and the tenant can manage different applications across multiple namespaces. So this is where namespaces. So few other challenges with the multi-tenancy are like namespace scope. I've like referred like tenant can be assigned with to one or more namespaces. But what if a user has to work with custom resource definitions, or uh, like different resources in Kubernetes are uh, like there are like different resources in Kubernetes which are where some of them are namespace scoped and some of them are non-namespace are not scoped in the namespace. For example, CRDs or the cluster role binding or cluster role, they are not namespace scoped. That means those resources do not live in a specific namespace. So how can we achieve multi-tenancy around those cluster scoped objects? It's not possible to achieve multi-tenancy around that. And always a user or like a team has to rely on the platform team extensively to perform any changes to these cluster level objects. And the cluster version, it is going to be the same for all the tenants, regardless of. That means it's always challenging for the team to come up with. For example, because the Kubernetes project is continuously evolving, and there are like different objects that are being used are continuously are deprecated, and then new features are continuously added. What if a particular team wants to work with the new set of features that are released in Kubernetes, but there are other groups in the organization that cannot that wants to use or like they are still using the deprecated features or the certain APIs. Certain APIs which will be removed in the newer version. So the cluster versioning is always like a challenge in a shared environment. And the other one other thing is like the cascading failures, like which is very critical, because let's say if one of like some of the nodes go down in the cluster, the then multiple tenants like try to fight for resources in the cluster, and then eventually like an impact that is created and or caused within a tenant will create a cascading impact, or like will cause impact on other applications as well. And the other like limitation is like the coordinated maintenance. For example, if the platform team has to do a cluster upgrade, then they have to talk to each and every, or they need to align with different tenants, make sure all the tenants allow us or are okay with the upgrade, because it just ties back to that cluster version. Like some of the features like that are being deprecated, or the application did not go through like a lot of changes in one application group or like application team. Um, team and it might be pulling the platform team to like to do or like to perform like the necessary upgrades. And these are like some of like the very few limitations, but like there are like many more limitations that are in that exist. So with that, let's talk about like vClusters, also known as like virtual clusters. Some of the limitations like that I have like listed here are addressed with the help of virtual clusters. So, so what virtual cluster does is it enables us to run Kubernetes clusters on top of another Kubernetes cluster. Uh, uh, that means like virtual clusters are fully working Kubernetes clusters on top of like other Kubernetes clusters, and compared to like the multi-tenancy, like in a single cluster where we create objects, and then we have like a dedicated platform engineering teams to manage access, and then continuously help users with the ad hoc requests. A user or like a application team is given a dedicated cluster, which will be deployed within the host cluster's namespace. And on this particular new dedicated cluster, the developers or like the application group can seamlessly work with any with any type of objects, like whether it can be namespace scoped or it can be a non-namespace scoped. I will like show that like more in detail in a demo, but I just uh, like few other like quick things is like this particular vClusters is developed by Loft Labs, and then they open sourced it recently. Now vClusters is part of like CNCF project. It's easy to get started, and also easy to use. Like you will be like seeing that in the demo. Actually, I can maybe switch to the demo, and we can come back to the architecture after that, so that we like how to start working with vClusters. So let me reshare my screen so I can show my terminal. Just checking the chat, and then everything looks good. Okay, let me continue. Okay, I'm going to use the Minikube cluster, which is like running locally with the help of HyperKit. So I just started the mini cluster, and then uh, going to start like we'll start using multiple like virtual clusters like right away. So before to start that, I'm going to use the guide. So here is like the documentation like for the vClusters. It's available at vclusters.com, and we can just like go through like the core architecture components like in a bit. So I'm gonna come and then start here like on the quick started guide, where we need to download a quick vClusters binary. A vClusters can be installed in different ways. It can be different ways, and there are like Helm chart that's available, or what this particular command does is it abstracts the Helm chart, like the way we run the Helm chart, like with all like the sensible defaults. So I have like went ahead and then installed the vCluster, and we can just see uh, vCluster version. That means like I have like a vCluster that is installed, and then I need to create a cluster. So in order to create a cluster, I just have to switch or like have the right kube context. And once I have that in place, we can simply create a cluster, vCluster, Mirantis lab, tech talk demo. So when I create this particular vCluster, what it is going to, okay, sorry, it's going to be vCluster create. So this will create create a cluster within my host cluster, like the host cluster is Minikube. And what it is going, which distro it is going to use is it is going to use K3s. K3s is one of like the lightweight Kubernetes distro. It also supports like multiple like different distros like K0s, like plain K0s, sorry, and then like plain Kubernetes cluster as well. Uh, and then we can also like spin up clusters of different versions. Like for example, if like if a team A wants to run 1.221, and then if another team wants to run 1.25, we can set the version and then have like different clusters for different teams. So now I like so the step like vCluster like create the cluster like says the cluster is created successfully, and the context also switched to the switched to the new cluster. So once we can just like run the respective commands to access the cluster space. I think my mouse got disconnected, so let me try another way. Okay, so I'm going to access these clusters just with the help of Lens. So I can easily browse through different resources and show you around different objects that it creates during the process and how it is managed. So here I'm on a Merikube cluster. I'm going to add a new cluster, which will be our virtual cluster. So this is the kube context name that it created when we use with the help of CLI. So I'm gonna like try connecting to the vCluster as well in parallel. And let me just pin this to hotbar. And these are like the two clusters that we'll be working with, like the first two. First one is the Minikube cluster. This is the host cluster, and then the second one is the virtual cluster. In the Minikube cluster, whenever we ran the cluster create, then what happened is it created a stateful set, and inside stateful set, like there is a pod with two containers. So these two pods that are created inside with the help of the stateful set is responsible for. So these two pods will are like the only two components that is needed to set up the virtual cluster. It's completely lightweight and easy to easy to start in a cluster. Now, going to the virtual cluster, we can see like the same set of pods, or like I can just click on all namespaces, and we can also see the list of namespaces. So in the host cluster, we have a list of namespaces. And let's say if I create new namespaces in the host cluster, they are not visible to the virtual cluster. Create namespace test1, namespace test2. And I'm in the virtual cluster. It's not available in the virtual cluster because the environments are completely isolated. But let's say if I create a new namespace called vCluster T1, this namespace I'm creating in the virtual cluster. and I'm going to create another vCluster test2, and these two namespaces are just scoped within this particular vCluster or virtual cluster, and we cannot see those clusters while accessing from the host cluster. So the way it does is, I think this is like the time to dive into the architecture. So the way it is achieved is with the help of like this architecture. The architecture consists of like the two core components. Like one is the below that we are seeing is the host cluster, and then the on top of on in the host cluster, uh, in a single namespace. Even in the host cluster, it's not touching all the other components. All it needs is access to a namespace. All a user, or like everything that a user needs, like for a developer, is access to a namespace. Once they have access to a namespace, they can deploy vCluster. Like in order to deploy vCluster, we don't have to rely on an administrator to install like a CRDs or create service accounts or like perform any complex operations. It's just easy to get started with. And as we discussed, like when we did this, so there is a component called like a sinker, and then the stateful sets, which are like the high level resources. These get deployed, like the stateful sets. The stateful, like the parts that gets deployed, which is like a control plane, and then the control plane part, and then the sinker uh, will help uh, will help sync the resources from the virtual cluster to the actual cluster. uh, when we look at the physical resources in a Kubernetes cluster, is they are just pods. Like everything that is around pods, like deployments or resource set, replica set or stateful sets, like cron jobs, like everything that we talk about. End of the day, they create a what do we call is they'll create a pod. So what vCluster does is it maintains a logical or it maintains like another API server which runs as a pod, and like Loft Labs develop this sinker, and this sinker will help synchronize the pods that are created in the virtual cluster to the host cluster, and they follow a specific naming, and we can look at that. So I'm in the virtual cluster, and I'm gonna come here and just create, and I'm actually going to create a simple deployment, and or okay, I'm gonna deployment of Nginx, and this is in the vCluster. So it's going to create 3 replicas. And when we create that, I think it's going to create by default. It got created in the default namespace. I'm going to use, uh, once they are created in here in the virtual cluster, we can access them, or we can, like in the host cluster, how they appear uh, is with this additional naming convention. Like only the pods are synchronized from the virtual cluster to the host cluster. If you look at the naming of this particular virtual cluster, it has like the Nginx deployment, which is like the standard deployment name that gets created when we create a deployment, and followed by X, and then the namespace which it belongs to, and then X, and then the virtual cluster name. So this is like the naming convention that they follow to maintain that uniqueness. And let's say if we create a new virtual cluster, and I'm going to make use of distro option. That means like this, the initial cluster like that's been deployed is using K3s. The virtual cluster is using K3s. But what we are going to deploy is with the desktop of K0s. So once, okay, I have to use a different name, desktop K0s. So now we have like two virtual clusters, which are of like two different distros, like they are also like of different versions. And Loft, and once this is deployed, we can actually see in the host cluster there is a new namespace that got added for the K0s, and inside this particular namespace, there is a stateful set or like a group of pods that it is trying to launch. And the pod names that we can quickly see. One is like a controller pod, and then what's the easiest way to get the pod names? Yeah, one is like the vCluster and one is called Syncer. So these are like the two components that I'm like referring to. So Syncer will help synchronize like the pod configurations from the virtual cluster to the actual cluster, and then in vCluster will help to maintain the cluster state. There are like several advantages in terms of having its own virtual cluster or like API server within this virtual cluster, because like right now, if like on a single host cluster, like every user interaction goes to the API server whenever we try to create new applications, scale them or not. And with hundreds of tenants on a large scale cluster, API server is going to become a bottleneck because it has to handle like thousands or like millions of requests, uh, and then work with like scheduler and like on like different objects. But when we have this multi-tenancy, the uh, all we have to interact is directly with to this particular API server, which we can configure using like an ingress object. And and all the scheduling like of our higher level objects, like the deployment configurations, like the replications, everything is handled within a container inside the virtual cluster, container like by the virtual cluster, and also with the help of Syncer. It eventually like reduces the load or like the number of requests that the API server on the main cluster needs to handle. Since we launched the new cluster, like the second one is running, I'm going to connect to the second cluster, and we can see, we can try to like browse the different resources. I'm going to start with namespaces. And in the host cluster, and then in the first virtual cluster, we created like few namespaces, but they are not available here because it's not necessary. Because it's completely isolated between both the environments. So uh, nice thing about the virtual clusters, where it provides like the true full isolation, and also it helps us to enable what do you call enable or like build clusters depending on the tenant requirements. Like now, like the host clusters for the host clusters to be upgraded, all we have to look at is if the pod specification in the virtual clusters uh, is in sync, or like does the specification like the version in the host cluster, and then the pod specification version in the host cluster, and then the pod specification version in the virtual cluster are match or not, is the only thing that we have to look at it. All other object configurations or everything apart from the part specification is abstracted. So if the part specification matches, then the platform team can seamlessly upgrade or like perform all the necessary the necessary data operations on the host cluster seamlessly, while the different tenants are while the different other teams have flexibility to run and manage their applications, run and manage like their own clusters and applications seamlessly uh, in as a virtual cluster in the host namespace. We just talked a little bit about like the architecture. Like I'm not gonna deep dive into it, but like the key thing that we have to remember is like it's completely lightweight and like as part of like the core thing that it's just creating is a stateful set, which has the syncer and then the API server and then any of that any helpful parts um, like DNS, core DNS, or other like core DNS and other things. And one other thing I forgot to mention is like the networking. So the way networking is done is like the vCluster does not like build like a new networking layer on top of it. It makes use of like the underlying networking features. Like if we like deploy Calico on the host clusters, it makes use of that like for communication, like by setting up all the necessary rules. So that's the basic. So I'm just gonna like quickly summarize on the benefits, since I hope like the demo is helpful where we can like see this isolated cluster. So just to summarize, we have built two different clusters on top of Minikube cluster. So the clusters are named like vCluster and Mirantis Labs Tech Talks K0S, and then vClusters Mirantis Labs Tech Talk Demo. So these are like the two clusters. And like as a result, it created like uh, few stateful sets. And then when we actually switch to the actual cluster and then try to look at the namespaces or the different objects that are being created, they are completely isolated with this particular vCluster. And let's say if something happened and I wanted to like start fresh on a vCluster, we can simply delete uh, like in the place where we have create, we can just like run delete command and then it will uh, remove the vCluster. So it's that simple, like creation and deletion of vClusters. So it's easy uh, for someone like who is like working on a POC or like trying to play with something else, but they are too far out and then they wanted to reset the state of the cluster, then it's easily possible. And there are like ton of other features that vCluster exposes, and we don't have like a lot of time to like go through all of them. But feel free to check out the documentation. It's all like well organized and well detailed. And also, if you like to contribute, feel free to check out the development tutorial and then the code base in the GitHub. Okay, few other things just want to summarize. Like, so I've like talked about like these benefits of vClusters, like where full admin access, you have like full admin access where you can work on like the new CRDs or like new custom objects as needed without heavily depending on the platform team to make changes on the host cluster. It's huge in terms of the cost savings, like both from the time and then like the resources. Because if you have to like build a multiple clusters, like clusters of multiple versions, then it can be done like seamlessly instead of building a new cluster with different versions for new requirements. And you can more efficiently use the resources in a single cluster, and it's also low overhead. We are not like highly dependent, or like a user is not highly dependent on a platform team to set up this virtual cluster. Like as long as they have access to a single namespace, they can start deploying in a virtual cluster. There's no network degradation because it's not because the vClusters like uses the underlying network configurations. So it's not uh, there is no network degradation. And the API server compatibility, like we can, so that's like so that's like the different CRDs or like different type of objects, like the versioning that I'm talking about, like which aligns with the API server compatibility. And it is secure, and security and scalability is achieved, like security because like of like the full isolation, and then everything around that we spoke about, and then the scalability is things can quickly scale. Yeah, like teams can quickly scale, and then the resources, everything can be quickly scaled with, because there is a lot of flexibility on the type of distro that it can use. Uh, and we can also like simulate like virtual nodes within a vCluster. So any labels that we create, etc., they are just specific to virtual clusters. And just like a quick summary of like having a separate namespace for each tenant, and then having a separate cluster for each tenant. Those are like the two common patterns in which the the- i- use in which like the multi-tenancy is implemented in various organizations, and it's been evaluated on these different factors like isolation, like access for tenants, cost, resource sharing, and overhead. Uh, vCluster like provides like a middle ground, like where we don't have to like build hundreds of clusters, like one for each tenant, and then enter into this cluster sprawl of managing these multiple clusters, like operationalizing them. That's like one challenge. And or like talking or like having a single cluster and like creating namespaces and going through an extensive development of or building platform abstractions on your namespaces, building platform abstractions for each tenant. So vClusters provides provides the balance between uh, having multiple clusters versus like having a single clusters and shared across multiple tenants. We also went through the demo, so I hope you all followed it, and then feel free to like check out the quick start guide and then try it out. So that brings us to the end of the Tech Talk. Let me see if there are any questions in the chat. Okay, I don't see any questions, but we do have like few more minutes. Feel free to post any questions that you might have. In the meantime, let me talk about like the upcoming webinars or like upcoming Tech Talks. Next week, around at the same time, we have a talk on serverless on Kubernetes using Knative. It's going to be given by one of our technical writer, and please do join us. Where we'll dive into the serverless concepts, and then how to get started with it, and then and then how serverless in the Knative world works, like how serverless can be achieved with the help of Knative on top of Kubernetes. And the following week, we have a talk on how we can protect the Kubernetes clusters uh, by setting up guardrails using open policy agent or gatekeeper. So we don't have like teams like trying to run like uh, uh, workloads out of the policies and that out of the organization policies. We can use the so it's like a demo rich tech talk where we will be configuring certain defining certain policies and then implementing those policies on the cluster, and then have users users follow the rules or like have those guardrails in place on the cluster. So with that, going to the next one is Team Mirantis is hiring for multiple roles. Feel free to check out Mirantis.com/careers, and apply for any roles like that you might be interested in, and will be nice to have you work for Mirantis. With that, that concludes our webinar. And uh, what happens next is you will be I'll be like sending out an email with all the information, like which includes the slides and the links to the vCluster documentation and the recording. Feel free to check out the recording at your convenience, and then if any of your friends or colleagues are interested in it, like please do share, uh, and also like do sign up for the upcoming tech talks. We'd love to hear your feedback. You can like respond to back to that email, or share the feedback in any medium that you'd like to, and we'll be happy to consider them and then implement it. Also, any like new topic ideas, feel free to share them, and we'll be happy to bring them to you. With that, I think it was we can conclude it. We are right on time, and thank you for being here. And I hope you all enjoyed it. Thank you so much for joining, and I hope to see you on in the upcoming webinars. Thank you.